In 4.1, we looked at quadratics in vertex form. Now we're going to look at quadratic functions in standard form and learn how to graph them and write them in this new format. First, though, we're going to look at some features of the quadratic function when it's in standard form. Here is the following equation, and this is the graph of that equation just from Desmos. We can look at the graph to identify some of those features. We still have a vertex here at the bottom, and our vertex occurs at x being, looks like a -2, and y is at -10. The axis of symmetry is still going to be that line that goes vertically through the vertex, so it's going to be x equals -2. Since the graph is opening up, we are going to have a minimum value, and that minimum occurs at -10. Our domain is still all real numbers for quadratics, and the range, since the graph is opening up, it's going to be all these y values that are greater than -10. So y is greater than or equal to -10. So if you have an equation in standard form, you can go ahead and type it into Desmos to get the graph and then identify its features. Before we move on to the next example, we need to review a couple of algebra skills. What if we had 4 divided by 2/3? Well, that's going to be the same thing as 4 over 1. Since we're dividing, we're really multiplying by the reciprocal of the second fraction, which is 3/2. This is going to come out to be 12 over 2, which gives us a final answer of 6. Next, what if we have a negative number being squared? Remember, this is -6 times -6. Two negatives being multiplied together make a positive, so our answer is +36. Lastly, what if we are squaring a fraction? Well, we need to distribute the squared to both the numerator and to the denominator. So we're doing -3 times -3, which gives us 9, divided by 7 times 7, which is 49. I probably should have done this first, but what even is standard form? Standard form is y equals ax squared plus bx plus c. If we're going to graph a function in standard form, it's important that we first know what standard form is. So it's y equals ax squared plus bx plus c. And a, b, and c are just numbers. They're the numbers in front of the given variables. We need to be able to identify a, b, and c from a given equation. Given this equation, we're going to do step number 1. We're going to identify a, b, and c. We're going to notice that a is the number in front of the x squared term. So a is going to be equal to -2. B is the number in front of the x term, which is 12. And c is the constant, which is -9. It's really important that you use not just the number, but also the sign that goes with the number when identifying a, b, and c. In step number 2, we'll find the axis of symmetry and the x portion of our vertex using this equation, -b over 2a. So x is going to be equal to negative our b, which we just identified above as being 12, divided by 2 times a, which above we said was -2. This comes out to -12 over -4, which comes out to be a +3. This means our axis of symmetry is going to be at x equals 3, and we can go ahead and sketch that line on our graph for the third step. So we'll have a vertical line through +3. Step number 4. Now we know that our vertex is going to fall somewhere along this line, but we need to find out exactly where it falls. We can plug the x coordinate back into this original equation. So we're going to have y is equal to -2 times x, which we now found is 3, all squared, plus 12 times 3, minus 9. Using order of operations, we need to make sure we square before we multiply. So we're going to have -2 times 9 plus, we can do 12 times 3, gives us 36, minus 9. That will leave -18 plus 36 minus 9, which all comes down to be +9. So this is the y-coordinate of our vertex. From step 2 and step number 4, we now know our vertex is going to be at +3, +9. And we're going to put that on our graph. Your vertex should always fall on your axis of symmetry. Next, number 5. We are going to plot our y-intercept. Remember, the y-intercept is where we cross the y-axis, and that occurs whenever x is 0. So if we took our equation and we plugged in a 0 for the x values, we're going to find that all the leading terms cancel out, and all we're left with is our constant. So this means our y-intercept is going to be at 0, -9, or it's just going to occur at that c value. So we'll plot that point. Now step number 6, we're going to plot the symmetric point. We're going to need to go 3 spaces to the opposite direction, and then we're going to connect these points with a nice smooth curve, the best that we can, even though they're kind of far away from each other. And here is the graph of our quadratic in standard form. We've looked at both standard form and vertex form now individually, but we can actually convert between these two forms. If we have an equation in standard form, like this one here, if we want to put it in vertex form, we have to know the vertex. We're going to find the vertex just like we did in the example above. We need to identify our a, b, and c value. So a is going to be 2, b is going to be a -10, and c is going to equal 7. To find the x-coordinate of our vertex, we'll use the -b over 2a equation again. This means x will be equal to a negative times -10 over 2 times 2, which gives us 10 over 4, and we can reduce down to 5/2. Now, to find the y portion, we need to plug x back into the original equation. So we're going to plug in 5/2 in place of our two x values. This means y is going to be equal to 2 times 25 over 4, because we have to square both portions of the fraction, minus 25 plus 7. We can simplify with our first term and divide both of them by 2, which will give us 1 and a 2. So y is equal to 25/2 minus 18. Now we need to get a common denominator to subtract. So we'll put 18 over 1, and we can multiply it by 2 over 2 for that common denominator. So y will equal 25 over 2 minus 36 over 2. After subtracting, we'll get -11/2 is the y portion. Now we have the information we need to substitute back into vertex form. The h and the k make the vertex, and we know a from the first step. In step number 1, we said that a equaled 2. So let's go ahead and write that down again. Then we found our vertex. The x-coordinate was 5/2, and the y is -11/2. The x is our h, the y is our k, and we already know the a value. So y is going to be equal to 2 times x minus 5/2, all squared, minus 11/2. This is going to give us the same graph as the equation in standard form, but now it's just in vertex form. The next problem's for you. This one does not have any fractions though. With this example, make sure that you're really careful with all of those negatives. The a value is a -1, since we just have a -1 in front of the x squared. After working through the steps, this is what you should get. Quadratic functions have lots of applications. One that you see but might not automatically recognize is a bridge. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function y equals -0.0005x squared plus 0.85x, where x and y are in feet. How high above the river is the arch? Let's draw a little picture. We've got our river below, and we have this nice bridge above, and the bridge has this arch to it. What we're trying to find is, what is this height right here? Well, we can see that our height is going to be the same thing as our y value, because it's a vertical change. That means we're going to have to find our vertex. And we find the vertex the same way we have in all the other examples. The x-coordinate is going to be equal to -b over 2a. Our a value is a -0.0005, and the b is the 0.85. So x is going to be equal to a -0.85 divided by 2 times -0.0005. This comes out to be 850. This means from the start of our bridge, we've had to go 850 feet to reach our high point. But to find the actual high point, we need to plug this back into the equation. Y will equal -0.0005 times 850 squared plus 0.85 times 850. Y then ends up being 361.25. So this means that our bridge is 361 1/4 feet above the ground.